Hello everyone, this is Math with Josh. This is the chicken nugget problem puzzle video, the slightly fuller version where I talk through the problem, my essential answer, and I leave a little bit of the work for you, but okay. So the problem, if you didn't see the little previous video where I asked it, is suppose at some restaurant we can order chicken nuggets and there's a 5-piece, an 8-piece, and a 12-piece option. If we can order any combination of those boxes, that is, any number of 5s, any number of 8s, and any number of 12s, what are all of the numbers of total chicken nuggets we are able to order? For example, 21 can be made by 8 plus 8 plus 5. Now, what I'm going to do with this video, just to be efficient with the length of the video and the clarity of what I'm doing, I'm going to show you how I found the lowest number after which you can do everything for sure. I'm sorry, let me rephrase that. I found a floor after which you can do every number. And what I'm going to leave to you is figuring out the biggest number under that floor to understand the biggest number you can't do. So for instance, again, if you want to work on this problem, now you need to pause it and work on it, because I'm going to introduce my answer after a brief 5-second pause here. Okay, so what I worked out is that the number 20, yes, it was 20, every number after 20, let's use the text box here. So what I discovered was that if x is bigger than 20, then we can always construct that number. The part I'm going to leave out here that you'll have to check on your own is what goes on underneath 20, because under 20 you have some numbers you can fill and some numbers you cannot fill. I believe that 19 is the greatest number that cannot be ordered. And the behavior below 20, for the sake of this video, is a bit chaotic. Check manually. If you want to look at those manually, you can do them on your own. But let's get into how I solved the main idea here. So I'm going to clear the text off the screen in a second so that I have the whole board to work with. Okay. So when I heard this problem, my thinking was that I wanted to find that floor, because if I can find the floor where everything afterward works, then all we have to do is check underneath the floor for any of the other information we want. That is to say, I'm looking for the property that goes on forever. And my idea was, let's say we're at, let's say we're at some number that's a multiple of 5. We're at some 5k. What we want to do, starting from some 5k, starting from 5x, right, where x is just some counting number, so we're at some number which is a multiple of 5. If we can show how to order 5x plus 1, 5x plus 2, 5x plus 3, 5x plus 4. If we can show a way, given that we're at 5x, how to turn the 5x into 5x plus 1, 5x plus 2, 5x plus 3, and 5x plus 4, that lets us construct everything after that 5x point. And what I mean is, so let's imagine we're at some big number of 5s. So we'll use 20, because this is my first guess that 20 might be able to work. So let's say we start at the number 20, which is 5 plus 5 plus 5 plus 5. If we can swap numbers to build 21, 22, 23, and 24, 25 will just add an extra 5 on, and we can repeat the swapping out process to get 26, 27, 28, 29. If it's a little bit unclear what I mean, the idea is, so let's see. So the actual thing I found here is we have 5 plus 5 plus 5 plus 5. I want to change that to get 21 instead of 20, and my options are, the options are removing 5s, adding 8s, adding 12s. And what you have to do a little bit of guesswork and check these things, but one thing you'll notice is that 5 plus 5 plus 5 is 15, and 8 plus 8 is 16. So we will swap 5 plus 5 for plus 5 for 8 plus 8. Get 5 plus 8 plus 8 equals 21. So that gets us 21. If we want to get 22, take 5 plus 5 plus 5 plus 5. Now we're trying to add 2 to this. And the thing you'll notice is if we replace 5 plus 5 with a 12, we get 5 plus 5 plus 12, which equals 22. So we've constructed 22. For 23, we take 5 plus 5 plus 5 plus 5. We need to add 3 to it. So, and how did I do this? That was a good question. I had a very cool approach, actually. 23, if we subtract 12, we get 11. That doesn't work. If we subtract 8, we get 15. Ah, yes. Replace a 5 with an 8. We get 5 plus 5 plus 5 plus 8 equals 23. 15, yeah. And then to get 24, 5 plus 5 plus 5 plus 5. Notably, we figured out that we can take 2 5s and replace with a 12 to add 2. So we can replace that with 12 plus 12, and we get 12 plus 12 equals 24. And of course, to get 25, we just add an extra 5 on. Now, this maybe seems like a lot of work, and you might be thinking, how does this, solve that everything after 20 can be made? Well, now that we're at 25, okay, I'm going to clear the board again. If you want to look at this a little bit more, you can pause the video. So, okay. So, we've proven that starting with 5 plus 5 plus 5 plus 5, we can construct the next 5 numbers. Now what that means is, 20 we can do, 21 we can do, 22 we can do, 23, 24, and 25. The catch here is that 25 is just 20 plus 5, and because it's 20 plus 5, we can keep repeating the same process as if we only had 4 5s available. What I mean is, if we wanted to construct 26, well, 26 is 5 plus 5 is, we want to construct 26. Well, 25 is 5 plus 5 plus 5 plus 5 plus 5. But what we learned is we have a technique for taking a pile of 5s and going up by only 1 using 8s and 12s, which is to remove 3 of the 5s. We replace 3 5s with 2 8s. 5 plus 5 plus 8 plus 8 is 16 plus 10 is 26. And we'll do that same thing to create 26, 27, 28, 29, and 30. 30 we just add an extra 5 on. And because we can create the next 5 numbers by swapping just 4 of the 5s, this process will let us keep constructing the numbers forever. So let's pick something sort of big just to prove a point. Let's say, how would we order 1,000,000 chicken nuggets? Practical life advice, if you order 1,000,000 chicken nuggets, they're not going to have that many in the store. But say we had 1,000,000 chicken nuggets. Well, so we wanted to order 1,000,004 chicken nuggets. Well, we know that 1,000,000 equals, let's see, 5 times 200,000. Want to increase by 4. We remember that our increase by 4 technique was replace 4 5s with 2 12s. So 1,004 chicken nuggets would be, let's see, 199,996 5 pieces plus 2 12 pieces. And so this tells you pretty easily that we can construct, in general, all the chicken nugget numbers above 20. Now, as I said, I left a little bit of work for anybody watching, and that's figuring out, what's the highest number under 20 that you can't construct. It's 19, but you'll have to check some numbers to prove, you have to see why that's true. Thank you very much to everybody that's watching. You can contact me wherever you're seeing this video. Thank you very much for watching. This is once again Math with Josh, and have a wonderful day.